All right, this is the notes for section 2.2. This is solving linear equations. In this one, I'm going to move through things. Remember that you can pause and practice and rewatch and do all those things. You have the control over the pace here. So as you have questions, stop and try things again and watch, okay? All right, so in this section, we're going to catch up notes, solve multiple step equations, talk through procedure, and then look at different kinds of equations. So first, we're going to solve just straight linear equations that have multiple steps. Remember before, the end goal is still the same. The key is to get the variable. Oh, I have the eraser for some reason. Nope. Variable equal the number. So the idea is to isolate the variable alone. When we solve multiple step equations, we're going to do the simpler things first. So when we can add or subtract, we're going to do that to start. Because the last thing we want to do is divide extra things, right? So if the last step is going to be division because like this is a multiplication, I'm going to get everything else out of the way first. It's sort of like clearing the decks to do the less painful thing at the end. So negative 2w minus 7 equals 11. The first step is going to be to do the opposite of negative 7, which is add 7 to both sides. Make sure when you do that, you're crossing over the equal sign. That's the both sides. So negative 7's cancel. I get negative 2w equals 18. And then the opposite operation for multiplication is division. So I'm going to divide by negative 2. And w is going to be negative 9. Remember always that you can check. So I could put that negative 9 back in here. For w, negative 2 times negative 9 is negative 18. Positive 18, pardon me. 18 minus 7 is 11. So we can check and see that we did it right. All right, down here, we're going to follow the same process for the second one. I'm going to add 5 to both sides. And I get negative 5y equals 15. And then the opposite operation here is division. So I'm going to get 5y equals negative 3. You can go through and check. It's a practice you should do regularly. I'm not going to check them all, but it is something worth you doing. All right, let's try something a little different. So in this one, what we see here is the same sort of thing, but we're multiplying by a fraction. So we're going to treat that a little differently, but we're still going to follow the same process. The joy in algebra is we're process oriented. So the steps go in the same order every time. We just have to pay attention to, the different sort of varieties of what's happening in between. So I'm going to subtract the 3 because it's being added from both sides. If you get lost, draw a line through the equal sign, and that will help. I get negative 1 equals 1/5 x. So when I write 1/5 x, it's really the same as writing x over 5. Those guys are equivalent. So this x over 5 is division. The opposite of it is multiplication. So I'm going to multiply both sides, but what's in the denominator, which is 5. It's going to cancel those 5s out. On the left, I'm going to get negative 5. On the right, I'm just going to get x. Okay, so let's try that same thing again. 2 equals half a minus 7. I'm going to start with the addition or the subtraction. In this case, it's addition. Add 7 to both sides across the equal sign. These 7's cancel. 2 plus 7 is 9 equals half a. Half a is the same thing as writing a over 2. Oh, that looks like a 9, doesn't it? Sorry. Let's make that look like an a. A over 2. So the opposite of that is multiplying both sides by 2 over 1. Okay, that's going to cancel the 2's. 2 times 9 is 18. So a equals 18, and you can go back and check. So if I put 18 in for a, 2 equals half times 18 minus 7. Well, half times 18 is 9, minus 7 is 2, so that works. So let's talk steps. When there's lots going on in the equation, the first thing you're always going to do is simplify. Get rid of parentheses, distribute, okay? You can't just get rid of them, you have to distribute. Combine like terms if needed. So if there are numbers to combine together, combine them. If there are variables to combine together, combine them. The second step, once everything is as simple as you can make it on each side, is to use the addition or subtraction property of equality, just like we've been doing, add or subtract things that are alone. And then we're going to do the multiplication or division that's necessary. Last step is always check your answer. So let's do something a little more complex. So I'm going to look at the left first. So on the left, I can combine 7 and 3. They make 10. On the right, I have parentheses. I'm going to distribute. So 2 times p is 2p. 2 times -3 is -6. Now, everything is as simple as I can make it, so I can do my solving. So I'm going to add 6 to both sides. I'm going to get 16 equals 2p. And then I can use the multiplication or division. In this case, it's division. So I'm going to get 8 equals p. And you can go back and check, and you should. Let's do this bottom one. It looks very similar. You could pause and try it yourself. It'd be crazy, right? All right, so on the left, we combine 12 and 2, we get 14. On the right, we distribute the 7. So 7 times 3 is 21, minus 7 times y. The thing I need to move to the opposite side is this 21. It's technically positive, so I'm going to subtract it. Minus 21 to both sides. So I get -7 equals -7y. I'm going to divide both sides by -7. -7 divided by -7 is just 1. So y equals 1. Go through and check. All right, let's do something slightly more complicated. Here's the thing. This looks terrifying, right? You look at it and you go like, oh my God. Same math though, same process. So the thing I want you to notice here is there's y's on both sides and numbers on both sides. When that happens, we have to get all the y's together and all the numbers together. The way we do that is addition or subtraction. So I just pick a side. So like I'm going to move the numbers to the right and the y's to the left. So I'm going to add 8.3 to take it from the left to the right. So I get 2.2y equals 6.2y plus, oh geez, I need to add 20.4. And now I can go through and move the y's. So this is the opposite of 6.2y is minus 6.2y. I'm going to subtract it. 2.2 minus 6.2 is 4. So 4y equals 20.4. And then I'm at division, so I'm going to divide by 4. Y is 5.1. Go and check. Okay. Now things are going to get even more complicated. So this is the part in the video where you want to really think and push through and like do these again repeatedly if you get lost, okay? So the first step is always the left. Let's look at the left. What can we combine? Well, I have a 2, I have a 7x, and I have a -5. I can't combine 2 and 7x. They're not the same kind of thing, but I can combine 2 and -5. So 2 and -5 makes -3 plus 7x. That's as simple as that side gets. On the opposite side, I can distribute. So I get 6x plus 3 plus 2x. And then I have x's I can combine together. So on the right-hand side, I'm going to have 8x plus 3. Okay. Now we're going to do what we just did in the last problem where we move things one way or the other. So I'm going to move the 7x to the right by subtracting it. So I get -3 equals 8 minus 7 is just 1x plus 3. That doesn't look like a 3. And then I'm going to move the 3 by the opposite operation to the left. So I get -6 equals x. It was not terrible. Oh, I did something wrong. Oh, I know what I did wrong. Do you see what I did? I didn't distribute all the way. That should have been an 18. So let's fix that. This should have been an 18. Aha, every now and then, even I make mistakes, which is why I check my notes, because once you're talking. So this should have been 18. So I'm going to make that an 18 minus 7x. That process was still the same, plus 18. But instead of subtracting 3, I'm subtracting 18. Silly me. If I had checked my work, though, what I would have seen is I did something wrong because it wouldn't have worked out. So x should be negative 21. Phew. This is why I check my work too. All right, you pause, you do this one yourself. See what happens, and then you're going to be able to check your answer. So I'm going to do the left first. I'm going to distribute. I'm going to actually distribute right this time, though. 8y minus 4 plus y. Well, 8y and one more y is 9y minus 4. And then on the other side, I'm going to combine the y's. 6y minus y is just 5y plus 3. Okay, simplified. So now I'm going to pick a direction to move. Let's see, I want to add 4 to both sides. And it doesn't matter which way you go at all. Just pick. So I get 9y equals 5y plus 7. And I'm subtract 5y. So I get, let's see, these guys go away. 4y equals 7. Okay. And then I'm going to divide both sides by 4. Y equals 7 over 4. That is an actual answer. Do not feel compelled to make it a mixed number. Do not feel compelled to make it a decimal. Leave it alone. Fractions are your friends. 7/4 is a number. It's okay. I know you had some teacher somewhere along the way that told you it was improper, but it's not. Don't be mad at it. It's a perfectly acceptable number. Leave it alone. Okay. So let's do one more. You try these. Okay. Pause the video, do them yourselves, see where we end up. So there's a little trick in this one, right? Look right here. This is a negative. The 9 is not being distributed. Okay, there's technically a -1 there. I'm going to distribute the negative, not have anything to do with the 9. Okay, so what I'm going to do is distribute that -1. So I'm going to get 9 minus z plus 3 plus 4z. So then on the left, I get 9 plus 3 is 12. Negative z plus 4z is 3z. All right, on the other side, let's see what happens. To distribute the 5, so I get 4z minus 5z minus 10, because remember the sign belongs to the thing behind it, minus 6. So 4z minus 5z is negative z. Negative 10 minus 6 is minus 16. Okay, now we're to those same 2 steps again, right? So I'm going to add z this way, because that makes sense in my brain. So I get 12 plus 4z equals negative 16. I'm going to subtract the 12. So I get 4z equals negative 28. Divide by 4. Z equals negative 7. And then check. Go put negative 7 in everywhere you see a z and see what happens. Okay? Should get to the same thing on both sides. That's how you know you're right. And if it doesn't, you did something wrong. Try this next one too. So I get 10, distribute the negative, minus x minus 5. Ooh, that's not a 5. Plus 3x. I'm going to finish this combining. So I get 10 minus 5 is 5. Negative x plus 3x is positive 2x. Equals, on the other side, I'm going to distribute the 5 again. 6x minus 5x plus 5, negative times negative, right? Minus 3. So 6x minus 5x is just x. 5 minus 3 is plus 2. And then combine. I'm going to move that plain old x by itself over. So I get 5 plus x equals 2, minus 5 to both sides. X is negative 3. Here's the thing, especially in this course, but in any math, The more practice you do, the easier this will get. Just practice. Give yourself the time. Be patient. All right, the last thing in this section is that there are 3 kinds of equations that we need to be aware of. The first is the kind we have been working with. They're called conditional equations. They're true for a certain value, and other values are false. So for this equation right here, this is a conditional equation. It's true when I put in -7. It's false when I put in 10. That's what conditional means, true sometimes. A contradiction is one that is never true. No matter what you put in, there's no solution. And then the third kind is an identity. An identity is true no matter what you put in. It works every time for every number, okay? So let's see what that actually looks like so we can recognize it. So here's what you do. You always simplify first, okay? So we go through the same steps we've been going through. So let's see, this side is simplified on the left, so I'm going to simplify the right. So on the left, I have 4k minus 5 equals 4k minus 6 plus 1. 4k minus 5 on the left, 4k minus 5 on the right. So you can see right now that both sides match. When that happens, this is going to be an identity. But if you didn't recognize it right away, here's what would happen. Let me get rid of those lines. I would add 5 to both sides. They would disappear. I would subtract 4k from both sides. They would disappear. I would get 0 equals 0. When I get to that point, I know that anything I put in, no matter what, is going to be true. If everything cancels away and you get zeros on both sides, it's an identity, okay? Let's look at the second one. I'm going to distribute. I get 2b minus 8 equals 2b minus 7. Now I want you to think about that for a second. 2b minus 8 is the same as 2b minus 7. That can't be. So this is actually a contradiction. But the way it looks, if you keep going, so we're going to do it over here, 2b minus 8 equals 2b minus 7. I can combine stuff. I'm going to add 8. I get 2b equals 2b plus 1. I get minus 2b minus 2b. Those guys all cancel. I get 0 equals 1. And that's never true. That's why it's a contradiction. I get to the end and I get a false statement, okay? And then let's try this one. So I'm going to subtract the 7 because you just got to start somewhere. I get 3x equals 2x minus 12. Move the 2x to the other side. And I get x equals negative 12. This is conditional because it says T-I-O-N-A-L. Oh, I forgot the T. Conditional spelling. This is conditional because negative 12 will work and 4 will not. Okay, so there are going to be some things that work and some things that don't. So you go through and try these. See if you can figure them out. What is what? Okay. See how it works. I will tell you that the first one is an identity. Oh my spelling is starting to fade here. D-E-N-T-I-T-Y. The second one should be a contradiction. And the last one should be conditional. All right, this is 2.2. So from here, go do the Alex assignment or the next video that's in this section, depending on how this section is structured, and continue forward. If you have any questions, you know what to do. You should ask, drop them into the discussion, or reach out.